Hello everyone, welcome back. And today for this video, we will continue look at the chapter 5, which is exponential and logarithm. Okay, and now for this video, we do for 5D, we call logarithm. Okay, so before we're doing anything about logarithm, we have to be really familiar with exponential functions. So in here, 2 to the power of 3 equals 8, and we write what? Log 2, 8 is 3. So it's read as the logarithm of 8 to the base of 2 is equal to 3. So essentially, these two expressions are the same thing. Okay, let's read this one again. The logarithm of 8 to the base 2 is equal to 3. Okay, so basically it means 2 to the power of what is 8, okay? This is a logarithm. But you're gonna ask why we need this one. So it's kind of like because before we have developed the computer or calculators, we sometimes need to use a lot of, the big numbers calculations. So if we're dealing with so many zeros, it's really easy for us, the human brains to make silly mistakes. So instead of doing that tedious and long numbers, we just make logarithm, and it's much easier because you will realize if I give you base 10, right, and I give you 1 million, okay, so yeah, 1 million should be another zero over here. Then it's just like 6, right? 10 to the power of 6 is 1 million, okay? It's much easier to record 6 and instead of 1 with 6 zeros, okay? And with this one, keep this one in mind, we can do this one. So this is asked 2 to the power of what is 32, so it's 5. And then ask 3 to the power of which number is 81, so it's gonna be 4. And in this book, actually, we ask ourselves questions, and they give us the context under the things. It says what power of 2 gives 32, and what power of 3 gives 81. Okay, this is pretty important, and this is the first step. We need to familiar with our logarithm and the link between exponentials. And another really interesting factor is they are inverse functions to each other. By inverse function, I mean if my base is greater than 1, my logarithm, it looks like this one, okay? And if my base is greater than 0 but less than 1, and it's gonna look like this. So it means their graph is symmetrical about y equals x, and the domain range are inverse to each other, or maybe let's say convert to each other, right? So these two equations are really important, or maybe I should say the formulas are quite important because we're going to use this one a lot to help us to solve the functions. Okay, for our later videos, I will show you how to use it. And currently, you need to remember this one and try to use as much as possible. Let's keep going. And another thing we call natural logarithm, which is e on the base. Okay, so just remember e is a number about 2.17. Sorry, 2.71. Okay, just a random number between 2 and 3. Okay, for this one, the laws of logarithms, the multiplication becomes addition, the division becomes subtraction, and the power can take out become the multiplication. This one is law 4 and law 3 actually is a similar because you can treat this one for special case when p equals -1. So it's essentially the same thing. You can remember them together. And for this one is this one. For a to the power of 0 is just 1, right? The a's cannot be equal 0. Whatever the other number a is, to the power of 0 is just 1. But a need to be positive, okay? For example 12, this is the normally question for practice, but not for our final exam. It's a good starting point for us to familiar with the logarithm rules. Okay, first we need to put 2 over here to become square. Then you multiply this together to get 9 times 16. And again, put 2 over here. The minus you become division. Okay, that's why you flip this one, 36 over 25 to 25 over 36. Okay, flip it, then you got the final answer. Okay. The next one is logarithm equations. So this is essentially the steps this book skipped. The formula I told you guys to use. So it means a to the power of log ax will be x. By that mean, so for both sides, we take the base 2 underneath. So all of this becomes the power becomes 2 to the power of log 2x equals 2 to the power of 5. So in here, according to the formula, in this case, our a is 2, right? Our x remaining the same, so x just equal 2 to the power of 5, done. And then it's like 32. For this one are essentially the same, but in here, you have to make sure you know e to the power of 0 is 1, okay? Just need to know that. And for the following one, it's a bit tricky because in here, you kind of do the multiplication, then you got something we call like square, right? So one square, you should get 2 solutions. In this case, it's 3 and x equal to 2. And just remember, always, you need to check because logarithm domain is always greater than 0. So you need to plug 3 in to the original equation, okay, in here to check if all the logarithms are valid. And then check x equal to 2 again to check if all the domain and equation are valid. Okay. For part B, even you only got one solutions, okay, as x equals 42 over 13, you still need to double check to see if this one is satisfied the condition, which means the domain must be greater than 0. Always check. And for this guy, again, this one looks okay, but in here, the part B, it actually triggers. You realize x can be the plus minus square root e plus 1. You see the note, but the original equation is not defined for x equal negative square root e plus 1. And so the only solution is x equal square root e plus 1. The reason why it's not defined because in here, you write them into ones. So once you write them together, it's possible to have a negative number times with a negative number, which means negative 2 times negative 3, for example, you still can get positive 6. So you accidentally involve with something you don't want to know. But this is a math, so you have to double check it will work. Then to convince or to show to the examiner, you consider all the angles possible and give the right choice for the final answer, okay? And in here, it's a bit tricky because now our unknown is on the base, which is on x. But again, you can keep doing the same thing. In here, it's a bit annoying because you have to realize it's x to the cube, then square root, or square root, then x cube. But another thing you need to realize is 27 is the cube root of 3. So after that, you can do this question properly. Okay, for this section summary, it's pretty important because we finally introduced our logarithm for year 12. I know everyone learned this one in year 11, but since it's not that, dealing with that not in enough time, so we need to make sure you can get the idea of the logarithm, which is this law and this 5 laws. And because of logarithm, it's really important. So for my next videos, I'm gonna do one more class for the exercise. Just focus on the book and to show you guys how I'm gonna do it. And for next video, make sure you click or press the pause button. So to make sure you try by yourself, then we can do it together and see my solutions. Okay, this is enough for today. Thanks for watching, guys. If you like my video, just click the like button and subscribe. Okay, see you guys for the next videos. Bye bye, guys.